Hey guys, and welcome back to the channel. Today I've got an interesting video for you guys, the inspiration of which comes from another YouTube channel. Check this out. Now, he has a channel where he makes and he tests armor, and his videos intrigued me, and I wanted to do some testing myself for maybe some future projects. So that's what we did today. I've got some footage to show you of a couple different test pieces and the results we had from those in our own testing. So if that's something that interests you, go ahead and stay tuned for the rest of this video. Hey guys, just a quick disclaimer before we get started. So I'm not recommending that you use anything you see here in this video for your own personal protection. If you're in the line of work or worried about bullets flying at you, I recommend going to a reputable source and purchasing legitimate body armor. I don't recommend that you spend time in your garage to try to throw something together in hopes that it works. But with that out of the way, let's get straight into the video. To start out, I want to talk a little bit about where the inspiration for this style of armor comes from. So modern body armor is generally some kind of ceramic strike face with some kind of backing material. And the rundown on that is that the strike face is used to break up the incoming round and distribute the energy from that solid piece into multiple pieces, which can then be caught by the backing material. So that helps us understand kind of the construction and the purpose for the materials we chose to use in this video. All right, so we'll start with the construction. What we used as materials, we used HDPE, high density polyethylene, as the backer. Now, real quick, this can be sourced from many different places. It's a common item. It's just plastic. So if you're familiar with 5-gallon buckets, cutting boards, drop cloths, plastic Walmart bags a lot of time, milk jugs, that material there that you're probably used to seeing every day, that can be ground down and melted into this material that you see in front of you now. So that's what provided us with our backer. And then the strike face was two 6x6 Capri classic tiles. And again, tiles, you can just buy them at Lowe's, Home Depot, any of the, places where flooring tile is sold. And the total weight for this test piece was 4.8 pounds. Now we went with 2 3/4 inches of HDPE. Honestly, if you weren't worried about trying to stop smaller caliber threats like 9mm after the strike face is gone, you could probably cut this down to less than an inch and save quite a bit on weight. But I wanted this armor to be able to, stop the maximum rifle threats possible with its ceramic strike face. And then even after the ceramic strike face is gone, I wanted there to be some level of armor value just from the HDPE. So that's kind of why we chose to go with 2 3/4 inches. All right, guys. So I already mentioned to you that this HDPE can be found in milk jugs and 5-gallon buckets and drop cloths. This particular test piece, we use drop cloth. And kind of one of the biggest downsides about using HDPE is the processing time. So if you're going to be working with denser pieces, like you're going to start with 5-gallon buckets, you're going to have some way to process those. And if you don't, you're going to spend a whole lot more time later on in the build process. So what we did is we took a drop cloth because it's already relatively compressed. If you just look at a roll of drop cloth from the side, you can see that it's the layers are stacked pretty close to each other, which is going to help you for the next step. But step one anyway is shredding that material, processing it up. So what we did is we just got some box knives and some scissors, and we cut layers of fabric to fit within our mold. The second process is that we took the second part of the process is we took all of that material and we heated it. Now, if you look up the flash point or the combustion point of HDPE, I believe it sits around 350 degrees. So you can take it up to right below that and let it sit in an oven for a prolonged period of time, and it'll eventually all melt down. And like I said before, if you're going to work with a heavier material, you really need to grind it up. Otherwise, that material has to sit in there for an extended period of time, just so that way all of the material in the oven can reach a consistent temperature, and you don't have any cold spots. This is really important because especially if you're working with smaller material, you don't want any kind of delamination, right? If you're doing a whole bunch of layers and you're not heating that evenly or thoroughly, you're going to get some delamination, and that's going to give you inconsistent test data. And that's something we found out. You've got to let it stay in the oven, generally for at least 4 hours. If you're doing like we're doing a 6x6 by 2 3/4 inch block, that can take several hours for everything inside of it to reach the same temperature. All right. So after you go ahead and you shred your material and you begin to heat it up in the oven, another really important step is that you take it out and you kind of knead it, and you try to make sure there's no air pockets within it. But kneading that will help you, get it into the general shape. And then after you get it into a kind of a general shape, you're going to want to put it back in the oven and heat it up some more. Because the next step is you're going to take it out and you're going to put it in your form, right? Now, we have done methods where you heat it directly into the form, and that's fine. There's nothing wrong with that. You can just put all of your material into the form. Generally, the problem you run into there is that you'll have to add material over time so you get the correct amount in the form. Whereas I think a more consistent way to do it's kind of an extra step, but that's to get the material heated and knead it together into a ball and then put it into your form. As far as the forms go, we built a couple of different forms. Wood is nice because the HDPE doesn't like to stick to the wood as much as metal. That being said, you're kind of capped on how hot you can go in your oven because you're obviously putting a combustible material in the oven. Now, we did make several wooden forms, and kind of the downside to those, other than you can't take the oven as hot, is that it's not as strong. So we had made a metal form, and the biggest downside of the metal form is you have to have some kind of barrier between the plastic and the metal. Otherwise, all your HDPE is going to be stuck to your plastic, and it is an absolute nightmare to try to get your test piece back out of that form. But after you have it heated and you have it placed the material back into a form, now the next step is to take it over and press it. And so that way you can get a consistent density and really keep air bubbles from forming as it's cooling. We tried a few without any compression whatsoever and just kind of kneading it and leaving it in the form. And those test pieces resulted in a lot of bubbles. And obviously, air bubbles in a material that's supposed to be stopping bullets is probably not the best thing you could do. It's a lot of wasted space. So go ahead and make sure that whatever you're doing, you add some kind of compression to it. We used a 20-ton press that we had in the shop to go ahead and squeeze the top and bottom of our form together. All right, guys, the last step is cooling, right? So you can either take the piece that is now pressed inside of the form and just let it cool inside the form, or you can take that form, put it back in your hot oven, turn the oven off, close the door, and just let it sit like that overnight. And that is kind of like an annealing process. Now, we weren't able to tell if this really helps or not. I don't think it hurts. I think it's generally a good idea, but it might be a wasted step. The long and the short of it goes like this, that as you're taking this material and you're heating it, you're realigning the molecules, and then when you compress it, you put a bunch of stress induced into the part, right? So that slowed, controlled cooling of the part, annealing, can release some of the stress within the part. So in theory, it's going to help you make a better material, but from what we were able to determine, it didn't make any difference for us. All right, now into the really fun part of the video. We're going to talk about what this actually stopped and what it wasn't able to stop. So we did all of our testing at either 12.5 yards or 50 yards, and we tested with 3 different calibers. We tested with 9mm, 223 and 5.56, and then 7.62 by 5.4R. Now, 9mm was shot out of a Canic. I think it's like a 4.5-inch barrel. All of the 5.56 came out of a 20-inch upper, and the 7.62 by 54R was shot out of an M9130 Mosin, which is like a 33.5-inch barrel. So other than the 9mm, we're pretty much getting max velocity out of all of these rounds. Now, the rounds we were able to stop. We're able to stop 9mm with just the HDPE itself, which is really cool. And like I said, we shot that at 12.5 yards and it stopped, so we didn't even have to shoot it at 50 yards. Now, the next round we tested was 223. Just some 55 grain stuff, FMJ. Now, we tested this at 12.5 yards, and I think we actually, yeah, we did test it with one ceramic plate, and it was able to stop the 223 with just one ceramic plate. We then stepped it up to M855, and we needed 2 plates to stop the M855. So that's 62 grain, and that has a small steel penetrator in it. And we were, like I said, we were able to stop that at 12.5 yards. The next caliber we were able to stop at 12.5 and 50 yards, but 12.5 being obviously the harder of the two to stop, was the Mosin firing FMJs. So some 147 grain off the shelf FMJs stopped at 12.5 yards, which I was very impressed with. I thought that's a lot to ask of some old plastic and a couple of floor tiles. But at 12.5 yards, we had no problem stopping, just your traditional FMJ Mosin stuff. Now, the next caliber we shot at it would have been M193. As you guys know, M193 is notorious for being able to defeat level 3 steel armor. Even though it's only copper and lead itself, it's just moving so fast. So again, out of a 20-inch barrel, 12.5 yards, we were able to stop M193. That's also very impressive. Now, the 2 rounds we were unable to stop that we did test, and we tested them both at 12.5 and 50 yards just to back it off, see if losing a little bit of velocity would have helped us. And I'm sure eventually, if we went far enough back or used a short enough barrel, we would have been able to stop them. But I was just interested in, kind of what we could stop reliably at all distances and at all velocities. So the 2 rounds that defeated the armor we created were M855A1 and 7.62 by 5.4 LPS. Now let's start with the 5.5A1. The 5.5A1 replaced M855. It's a similar round, but instead of it having any lead in it, it's now just the steel penetrator and copper, right? So it's a lead-free round that the Army developed, so that way they weren't filling the hillsides with lead, I guess. This one, a lot of people have tested it, different various YouTube channels, and we happen to know that it's really good at penetrating light armor, right? So this round out of a 20-inch barrel is moving pretty fast. It proved too much for the ceramic. So the LPS round performed very similarly. At 12.5 and 50 yards, it also penetrated. It also has a steel core in it. And I think really what it came down to, the reason why we were able to stop M855 and not the 5.5A1 or the LPS is just the size of the penetrator. So when those rounds initially strike the ceramic tile, all of the rounds that were copper and lead were immediately separated into several pieces, and the HDPE had no problem stopping them. But the rounds that had a large enough steel penetrator and were able to retain enough energy due to their mass were able to push through it. Now, an interesting result is that, as you can see here on the back of it, and I'll put some close-ups in it, this round came out sideways, and that was actually the LPS at 50 yards. So that penetrator is tumbling and losing velocity, which lets me know that we could probably stop it if you had a short enough barrel and you backed it off at a far enough distance. You probably reduced the velocity of that penetrator enough to be able to stop it with the ceramic and HDPE. But the long and the short of it is that this combination of 2 pretty classic ceramic tiles and 2 3/4 inch HDPE block works really well at stopping any copper and lead projectile, I would assume, other than something at a super high velocity. Like, I bet 300 Win Mag would probably sail straight through it. That's a very spicy round. But your traditional kind of hunting rifle and below, anything from like 308 and down, 5.56, 7.62 by 39, all those calibers. If it's just copper and lead, this armor system is going to have no problem stopping it. Your biggest concern is going to be keeping your ceramic intact. So obviously going to some mosaic tile and maybe adding some foam in between the layers to reduce the amount of cracking on different pieces of tile could go a long way. But I think the limitations of this armor is really the steel penetrator. Rounds that have that just kind of tend to sail right through it. All right, guys, let's talk about the pros and cons. So one of the best pros about this is that it's pretty cheap, right? You can go to the store and you could buy some closeout tile, and you could save the milk jugs yourself, and you could do this for a very, very low cost. And with that, not only is it cheap, it's also readily available, right? Like the milk jugs, if you're just saving them yourself, or if you just have like a drop cloth laying around that you're not using, and the ceramic tiles are, sold everywhere. So this stuff's, cheap and available. Now, some of the cons to it are that it's pretty heavy. So at 4.8 pounds for our test piece, and again, 6 inches, 6 inches, 2 3/4 inches. So those are the dimensions, and we're already at almost 5 pounds. That's pretty heavy, and that's definitely a con when you start to consider any armor. I mean, short of building a concrete bunker, which doesn't have to go anywhere, armor weight's always a factor. So if you're looking at building armor for anything else, it's definitely a trade-off. The more armor you have, the less mobility you have, and it's something to consider. The other big con here is that it's weak against steel core, as we found out through our testing. So, and steel core ammo isn't super common, but it is around. So, and it's not that hard for most people to find and dig up some steel core ammo if they're interested in testing with it. So that is just something to keep in mind. And the last part, and this one, I mean, you could probably get it down to less time, but another con is that it's pretty labor intensive. Throughout the course of this video, I lost track of how many blocks we made, but it took up most of the day to end up making a block. Between processing the material, heating it, kneading it, constantly checking the oven, see what the status of it was, putting in the press, allowing it to cool, trying to monitor all of the different steps in this process, and at the end of it, only having one piece. Now, of course, you could scale that. You could make multiple forms. You could buy some kind of machine to process the material for you. These are all things you could do, but I would, if you're just out here making it one test piece, you're going to see how labor intensive this method can be. Now, as far as uses go for this, like I said before, I don't recommend using this for body armor. Even if it had stopped some steel core stuff, I would just recommend you go out and you buy, a reputable dealer's armor, and just go with that. Level 4 stuff that's common today will stop steel core threats, and it's readily available at not that expensive of a price. So just go out, do your research, pick a company, go with some some sappy plates. Other than that, you could use it, I guess, if you were building a bunker or something. But then again, you could just also pour concrete. Concrete is pretty effective at stopping bullets. Now, an application that you might not have thought of that could definitely be a possibility is some kind of vehicle armor. If you wanted to build, a Mad Max style Jeep or something, you could probably take this stuff and get it to a point where, you're armoring specific areas, probably not the whole thing, and just, you're not making an MRAP in your backyard or anything, but what you are doing is increasing the survivability of being inside of a vehicle if it were to get shot at. Hey guys, I just want to thank you for watching the video. It's time to wrap this thing up though. If you liked what you saw, go ahead and hit the like button. And if you want to see more stuff like this, subscribe to our channel. We are a small channel, and these types of videos are particularly long and cumbersome to make. We enjoy doing it, and we hope you enjoy watching it. So thank you for all your support we've seen so far, and we'll catch you guys in the next video.